Hi everyone, this is Sam, and I just came back from the RedHat Summit. It was pretty exciting. It was my first time, and a lot of new announcements and really cool stuff. But however, in this video, I wanted to talk to you about Sysdig, what we were demoing at the booth. So if you missed us, you can catch the demo in this video. Hopefully you enjoy it. Thanks. Alright, so now I have the OpenShift 4.0 console right in front of us on the screen here. And one of the things that was talked about quite a lot at the Red Hat Summit and also at the OpenShift Commons was the concept of operators. And what an operator is, if you're not familiar with it, it's basically a way to package your application and how to maintain it with upgrades, pretty much take care of the life cycle of that application. And you can do this programmatically, so you program that and think of it as a sysadmin, installing an application, taking care of it, upgrading, and so on. So at Sysdig, we created an operator for the agent. There's also one for Falco. But basically, you can install the operator on your OpenShift cluster straight from Operator Hub. An Operator Hub is integrated within OpenShift 4.0. So once you install that, there are a few parameters that you can add as well. You can then install the Sysdig agent straight from the operator. So that's one thing we've added. Once you've installed the Sysdig agent, you'll find that we'll automatically discover the infrastructure that you have. So if you're running Docker as the runtime, probably for older OpenShift clusters, you'll also see Kubernetes is being used. But for OpenShift 4.0, as you may know, they're now going to be using CRI-O as the runtime. So we've added that functionality into Sysdig as well, so we have you covered once you move to OpenShift 4.0. Now, in addition to the infrastructure that we automatically discover, we also automatically discover all the applications running in your cluster. So you can see here some Mongo, Go applications, Cassandra, Postgres, MySQL, and so on. Now, as you can see here, we can give you a high-level overview of your entire infrastructure with some metrics, as you can see, CPU, memory, file system, network metrics. But we can also see the different clusters that you have. And these clusters could be local, on-prem, they could be in a public cloud somewhere. It doesn't matter to us. The agents will report back to the backend, and we'll see everything in one place. In this case, I've got two clusters, OCP 3.11 and OCP 4.0. If I expand these, you can see all the namespaces inside each one of those clusters. And the top here shows you the hierarchy, starting from a cluster name to the namespace, to the deployment, pod, down to the container ID. So if I decide to open up any of these, I can do that here. You can see this namespace has multiple deployments. Inside the deployment, here's a pod. Open the pod, you can see the container, and the container is running CRI-O. You can see it here from this icon. Now, if you notice, OCP here, OCP4, has added a lot of namespaces that are not necessarily important to the app owner. It's mostly for the infrastructure folks. So it's a lot of noise for somebody, trying to look at the performance of their application. So in Sysdig, we have the concept of teams as part of our RBAC model. And you can define a team like this one here, the application development team. And really what they're concerned about are four namespaces: example Go app, example voting app, Docker stats, and store frontend. So if I pivot over to this particular team, as if I were a member of this team, all of a sudden the 41 or 42 namespaces that I had earlier are all gone. I only have one namespace here in this cluster and four namespaces here. When we showed this at our booth, it resonated with a lot of people to reduce the noise, make sure that folks are only looking at what matters to them. Now, if I do expand any one of these, I can again see the deployments within a namespace. But one key feature I want to show you is the ability to see topology views for any of your applications. So I'm looking at this over the last hour. I can change the time frame at the bottom, but specifically for this, I can see the components of this particular application. This application is called Store Frontend. That's the namespace. Inside of this namespace, I have 3 deployments, and I can continue to open up the deployments and drill down from the deployment down to the pod, to a container, all the way to the process that's running inside of that container. You can do the same thing on the database side. You can see MySQL daemon running here, and I can see the response times that are going between my different microservices. Now, in addition to that, I can also see if there's any connections or going out to external services outside my cluster. In this case, we would either display the IP address or, in this case, the host name. So this is helpful from a security point of view to understand exactly where your microservices are talking to. If they're talking to external services, you can find that right over here. Now, in addition to that, you can also do things like show me my some of the dashboards that I can view here once I go back to the super user. Show me my capacity. So my OpenShift capacity dashboard, I want to see, how many allocatable CPU cores do I have for my specifically for my OpenShift 4 cluster. What's the allocatable memory, what's the requested memory, and so on. So this dashboard really helps me to do some capacity planning, and also do capacity trending over time, and so on. This is over 1 hour, but of course I can bring this back over days or weeks. Now, in the new console, you can, and I think they've Red Hat has also added this in 3.11, but there are dashboards they've integrated with Grafana out of the box as well, so that using Prometheus you can see some of the health and performance of your cluster. And going over here and looking at some of the dashboards that OpenShift has out of the box. And for some organizations, they really like Grafana and like to be able to view this in Grafana. So some of the out-of-the-box dashboards that come with OpenShift are great. We also have the ability to use the Sysdig backend as a data source for you, and that way you can visualize the dashboards that we have. Instead of visualizing it on the Sysdig UI, you can see it on the straight on Grafana as well. So now you can use Grafana for both the built-in dashboards for OpenShift, in addition to dashboards that you want to see in Sysdig, right in Grafana. So now pivoting over to the Sysdig Secure side, so a few things we can do. We can tie into the registries, the internal registry of, let's say, OpenShift 3.11 or OpenShift 4, and we can scan the images that are in those registries. One thing I like about this is that you're able to also view the runtime. So runtime images, basically within an hour period, I can tell you how many unscanned images, how many failing, how many passing images. And the reason why this is important is, let's say today you've scanned an image, you deem that it's good to go, you push it into production. A day later, a new vulnerability gets introduced into the image. We won't go and scan the image again because that adds overhead, unnecessary overhead. We already know the image digest, we know the hash for that image, and if a new vulnerability shows up, we're going to go in and let you know that there's a new vulnerability. We'll tell you exactly how many containers are running with this new vulnerability for this particular image. In addition to that, we can also see that we're scanning, in addition to operating system vulnerabilities, also non-OS vulnerabilities, which goes beyond the image scanning that's offered by OpenShift. the registries in OpenShift. So you can see things like, gems for Ruby, NPM, Node.js, Python, Java libraries, and so on, if it's available in that image. In addition to image scanning, we also have the ability to do compliance. So CIS, Docker Bench, and Kubernetes Bench, if you're familiar with those. CIS is the Center for Internet Security, and these are hardening compliance rules for both these, and it's about 230-page document for each. So we've added this right in the box to be able to run a schedule or a task for either or both Docker Bench and Kubernetes Bench. So this runs using our agent directly, and I usually recommend to run this once or twice a day in production, whereas in dev you probably want to run it once a month or once a week. So the results that you'll get something like this for Docker Bench. The different sections of the Docker Bench document, we show you what's failing, what's a warning, what's a pass. And if there is a warning or a fail, we show you the remediation steps. So what commands you need to run to be able to pass this compliancy. Now, the third thing we talk about in security is policies and runtime security. So we have a lot of policies out of the box that you can use. And if we take a quick look at one of those policies that have triggered, this policy here, terminal shell in a container, which basically tells you that somebody did a terminal shell in a container, and you typically don't want somebody to do that. It's not something that should be done in production. In dev, yeah, maybe if you want to test something, but once you're in production, you shouldn't be doing that. So if this happens in production, you should kill the container and move on and respawn a new one if you need to. But here we give you the actual scope. So this happened in the store front-end namespace for this particular deployment called WooCommerce. This particular pod, here's the container ID, on which host, a brief summary of what actually happened. Somebody did a shell in a container with user root. I can even show you the commands that were executed inside of this container. So bash, that's what started everything. They did the decryption. They actually downloaded, they curled something in from this particular path, give you the full path into which working directory. They untarred and unzipped the content of that folder that they downloaded, and they shredded their bash history after they were done. So even if they didn't shred their bash history, this container could have died, or the orchestrator could have rescheduled it somewhere else. And this is why it's very important to have something like Sysdig to save and store all this information in the backend, so you can come back and take a look from a forensics point of view. Now, we have the ability to do what we call captures. These are system captures, similar to Wireshark's PCAP capability. We have this capability here to look at every system call that occurred in a certain time period. We define this certain time period here to be 30 seconds when this particular event occurred. As you can see here, the event occurred at this particular time. We've recorded 10 seconds before, and you can see 20 seconds after. We have the ability to record before the event to find out what's going on before the actual trigger. This is possible by our rolling buffer that we have. If I click on different tiles here, I can see in time when these things got executed. So I saw 8 commands getting executed around the time where the event was triggered. I can drill in and find out, again, here are the commands that we saw earlier. But really I'm interested in this particular tar command where I untarred the files. And I want to know the content. I want to know the files that were made up of, inside this tar file. So you can see every single file that was in there. You can see some C files, header files, README, and shell, Python. And I can even go into see the contents of those files, as you can see here. And this happened to be a rootkit that we grabbed from one of our customers. I'll obviously massage the data here to remove any private data and to use it for our demo. But basically, this shows you the ability to dig really deep into what occurred on in this particular container, get to the forensics. In a real world scenario, if somebody's trying to do a terminal shell in a container, we will shut them down right away. And you have that ability in the policy itself. So if I go back to that terminal shell and container policy definition, I can see that I defined it for a specific namespace. I said, okay, only notify me because I want to show you this in the demo. But you can always kill the container, so stop or kill the container, pause the container as well. So you can take action against this container. And here's where I'm storing the capture 10 seconds before the event occurred and 20 seconds after. And finally, you can have a complete commands audit of every single command that ran in my environment in a given time period. So if I look at the last 10 minutes, I can look at the entire infrastructure or a subset of the infrastructure. So if I look at the entire infrastructure and see every single command that was run in the last 10 minutes, I have it here with the scope for it. So if it's running directly on the host, you'll only see the host. Otherwise, you will see, depending on the grouping that you have here, you see what namespace, deployment, pod, and container ID as well. You can search through these commands and you'll see all the commands that are running as well. So hopefully this has been helpful for you guys to see what we've been demoing at Red Hat Summit, and thank you for watching.